Hello everyone. In this video, we'll be solving problem 498, diagonal traverse. The problem statement is, we are given an m by n matrix. We need to return all of the elements in the matrix in the diagonal order. We start with the first element in the matrix, that is 1, and move upwards. And once we hit the ceiling, we then switch the directions and start going downwards. So after 1, the next element is 2. And if we continue going downwards in the diagonal direction, the next element is 4. And as 4 is the last element in that diagonal, we'll pivot or change the direction starting with 7 as the next element and move upwards. And during the traversal, all of these values should be recorded in an array and returned as the output. The problem statement is very easy to understand. Let's switch to whiteboard and discuss how we can solve this problem. Let's start by identifying some of the rules that will help us come up with a solution. As there are two different directions, upwards and downwards, we should have different set of rules for each of them. Starting with the upwards direction, when we want to move to the next element, we will have to decrement the row pointer and increment the column pointer. And for downwards, we are basically incrementing the row value and decrementing the column. I hope this part was clear. The next thing we need to be careful about is the validations to make sure that the pointers do not go out of bounds. If our pointer is pointing at element 1 and we decrement the row value, it will become -1, which is out of bounds. Ideally, the pointer should be shifted to the next element in that row, that is 2, along with changing the direction. The same logic applies when we are going in the downwards direction and we reach the last element. Let's say our pointer is pointing at 7. There are no elements after that, so we need to now change the direction and increment the column value. So this logic of incrementing the column pointer applies to both the directions. Here's the mathematical representation of the logic that we just discussed. If the row pointer is greater than or equal to r max or less than 0, we should increment the column pointer by 1. There's one more case that we need to take into account. Let's say my pointer is pointing at 3 and we are going upwards. After that, there is no element, so we should ideally increment the value of the column pointer by 1. But there is no more column after 3 as it is the last column. So we'll be again getting out of bounds error if we use that logic as is. So instead we need to increment the row pointer so that we can switch to 6 and then change the direction to go downwards. To support this criteria, we also need to take into account the column value. The logic is very similar, where if the column value is greater than or equal to column max or less than 0, then we should increment the row value by 1. This logic applies to both upwards and downwards direction. If we can implement these three rules, we can easily solve the problem. With this solution, this time complexity is going to be O of m into n, where m and n are the number of rows and columns in the given matrix. This is because we are traversing through the input matrix only once, while the space complexity is O of 1, as we are not creating any additional collection besides the one where we are recording the values that needs to be returned as the output. If we include that into the calculation, then the space complexity will be O of m into n. I hope you are able to understand the explanation. Let me show you how we can implement this using Python. In this Python implementation, I start by adding a validation to make sure that the matrix is not null and there are at least one row available in it. After that, I've initialized few variables to use as a pointer and a variable result, which is an array of type integer. After that, I'm writing a while loop to run until the IDX pointer is less than the total elements in the given matrix. If the upward flag is set to true, the first check is to verify if column is not equal to column max. If the condition is met, it means we cannot go any further, so I'm incrementing the row pointer by 1 and setting the upward flags to false. Else if the row is equals to 0. In that case, I'm incrementing the column pointer by 1 and setting the upward flags to false. If either of the conditions are not met, then I'm decrementing the row pointer and incrementing the column pointer. Let's say we are going in the downwards direction, and the code will enter this else block where we'll first check if the row is equals to row max. If yes, then I'm incrementing the column pointer and changing the direction. Else if I'm checking if the column is equals to 0. If yes, then it means we cannot go up downwards any further. So I'm incrementing the row value by 1 and changing the directions. If either of the conditions are not met, then I'm incrementing the row pointer and decrementing the column pointer. Once this while loop is complete, I'm returning the results array as the output. This code when submitted on LeetCode beats nearly 82% of the submissions in terms of runtime and nearly 34% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.